9.4 is called is called equations in quadratic form. So if you recall the quadratic formula, if you're given ax squared plus bx plus c equals 0, then we can solve very quickly for x using our formula here, negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Now, what's great is, if you remember where this came from completing the square. You can prove that formula. At the end of the day, you just need to know this. And so a really, really nice way to solve any quadratic equation just by plugging in the values of a, b, and c. So we're going to take this one step deeper. We're going to look at equations that are not quite this form exactly, but they're very, very close to it, and there's going to be something that's been adjusted, I think is a good way to say it. Now, likely that a lot of you guys just watched the videos for 9.3, but in case it's been a few hours or a day, let's go back and do one example just using the quadratic formula, and that's going to lead us really well into our first example here of things in quadratic form. So imagine you have this 2x squared minus 5x minus 3 equals 0. You say, okay, that looks like ax squared plus bx plus c equals 0. I can see that a equals 2, b equals negative 5 because I take the negative with it, and c equals negative 3 because I take the negative with that. Oh, it looks like I wrote all these things out over here again. Okay, if I plug all of these in, negative 5 plus or minus negative 5 squared with parentheses, minus 4 times a times negative 3, all of that divided by 2 times 2. Then it's just a matter of simplifying all of this. Well, we have a negative, that's going to cancel. 2 times 2, we can easily do that. I like to compute, grab a calculator, and do this whole thing. I'll do it along with you guys. So with parentheses, negative 5. I'm like blocking the page while I do that. Negative 5 squared minus 4 times 2 times negative 3. I got that whole thing to come out as 49. All of that, 49, okay. So I bring it to this step. At this point, I either simplify as much as I can or do the whole thing and square root 49. Hey, that's really, really good. That's just 7. So I have 5 plus or minus 7 all over 4. And at this point, I want to go further, so I'll have to think of it as the two separate equations, I guess. X equals 5 plus 7 over 4. X equals 5 minus 7 over 4. And doing these one at a time, 5 plus 7 is 12 divided by 4 will give me 3. 5 minus 7 over 4, well, that'd be negative 2 over 4, negative 1/2. So I've got my two answers. Okay, this is the type of example we did, obviously, back in the previous section. So how is that going to help us with these things called in quadratic form? So here's what we're going to do. In this section, we're going to be given things that look close to a quadratic, but something is a little different. Okay, so the problem we just did together was 2x squared minus 5x minus 3 equals 0. In our question, part A, we have 2 times x plus 4 squared minus 5 times x plus 4 minus 3 equals 0. And what happened here? didn't we simply replace these x's with x plus 4 and x plus 4? So where we used to have x, we now have replaced it, or you might say we have substituted x with x plus 4. Okay. So what does that mean? Turns out we can still use the quadratic formula with a as 2, b as negative 5, c as negative 3. But this time it's not going to be x equals it's going to be x plus 4 equals. So here I'm kind of indicating the x has become x plus 4 squared, x plus 4. So in the quadratic formula, we're going to just do the same substitution, or the same replacement. Instead of x equals, it's now going to be x plus 4 equals. But we can still use all those same values of a, b, and c. And this is a really, really, really clever way to solve something like this. Now you might be thinking, hey, couldn't we just multiply all of this out? I could FOIL that and then distribute the 2. I could distribute the negative 5, and I could combine like terms, and certainly you could. But when you see that connection, oh, I can just go for it. I don't have to do all that algebra and multiplying and FOILing. I can think of my a, b, and c just like this. I just won't make it equal to x. I'll make it equal x plus 4. So let's see how that plays out. And I'll tell you now, you know, when you see this sort of thing and it just clicks, we're looking for that light switch to go on and that light bulb to light up in your head. As soon as you see this, you can't not see it. But this very idea of replacing like x with x plus 4, sometimes that's hard for it to just like hit you. So obviously we'll do another example as well. But really we're looking for that light switch to go off, like, oh, it's the same procedure. I'm just going to call it x plus 4 equals that. And then we'll see that's going to change. There'll be a little bit more to the problem at the very end. All right, anyway, let's go for it. Let's plug in our a, b, and our c and make it equal x plus 4 now. So again, instead of x equals, it's x plus 4. Plugging in, and well, these are all the same values that we had in that example problem we just did together. So it cleans up the same way, right? We still get positive 5, 49 under here, 4. The square root 49 is 7. Right? 5 plus or minus 7 over 4, it's just equal to this now. And we then need to split it, right? Just like this in the same way. Make it 5 plus 7 over 4, 5 minus 7 over 4. I know I'm going through this really quickly and you're writing it all, hopefully. Should be writing it all for your own note-taking purposes. And okay, we're going through the same steps. This is still going to give us 3. This is going to give us negative 1/2, just like in the previous question. The difference now is we don't have our answers yet because it's not an x here. It's x plus 4. So there's one more step to both of these. We need to subtract the 4 in each case. And so here, if we subtract 4, we'll get negative 1. Here, if you subtract 4, you'll get negative 9 over 2, or you could use a decimal there if you prefer, negative 4.5. The key is, again, like it's just that light switch going off. Once you see it, it's like, oh, well, this is basically the same questions that we did in 9.3, but now there's this extra step of recognizing that in the first place and making it x plus 4 equals your quadratic. And there'll always be one extra step at the end to isolate the x, since we had the plus 4 in both cases. Okay, so I'm going to stop this video here. We got one more example coming up in just a moment.